Yeah, so I changed my talk title because I thought I would talk directly to the book because I had to read it for the second time for this and realized how much I liked it and disagreed with it simultaneously. Anyway, I sort of like this cartoon. So when it comes to mind, this sometimes does feel a bit fruitless. So I'm going to try and get right into the heart of what I think is going on with Mazviita and her book. Congratulations, by the way, much deserved. So this goes to chapter 10, the very end of it. The conclusion of the chapter and of this book will be to vouch for a philosophy of mind that pursues its course independently of neuroscience, mixed with pessimism about the viability of a scientific program that is truly sensitive to the integralness of the mind's place in nature. In other words, this kind of 4E kind of perspective is almost as though only philosophers can deal with it, and neuroscience have to engage in what they do, but because they have to engage in what they do, they will never solve the problem. That's basically. And at the core of MC, that's Mazviita Chirimuuta, which I'll save throughout the rest, are two related things. Consternation at the material indifference of 20th century Cartesian neuroscience is simplifying functionalism inspired by and misled by the artifactual separation between software and hardware and computers. And then related, a denial of the thesis that mind, brain, and the rest of the body are made up of quasi-independent components, as exemplified by Herbert Simon's hierarchical near-decomposability of the CNS. So basically, these are the core irritations spurring Mazviita on, right? And they're not unrelated, as you will see. And how do I describe this? I'm sympathetic with so much in the book, but these, I think, are both wrong. Okay, basically. But I'm sympathetic as to why it's been frustrating to get to that point, but it's just, in my view, one doesn't need this pessimism. Except for one thing, which I'll say at the end. So this is this book, article that everyone should read. Phil Anderson, solid-state physicist, one of the founding members of the Santa Fe Institute, and this incredible paper, More is Different, and basically has, the X's and Y's, but this hierarchy does not imply that science X is just applied Y. At each stage, entirely new laws, concepts, and generalizations are necessary, requiring inspiration and creativity just as great a degree as in the previous one. Psychology is not applied biology, nor is biology. And the point here, what Phil Anderson was saying, is this is an ontological fact. It's not an epistemological fact. There is no favored ontological object. It's not particle physics. And actually, it was hilarious to see how Phil Anderson would argue with Murray Gell-Mann, and then Murray Gell-Mann's sort of inheritor, Stephen Weinberg, who sort of had a mixed view of this stuff. So these are autonomous levels, ontological, not epistemological. So basically, a philosophy, sociology, and these are totally legitimate, equally valid disciplines. And the same thing happens for the nervous system. The way you talk about action potential, stretch reflexes, CPGs, eye movement thing is different. There's as different as these are different disciplines. The mistake that's been made in neuroscience is because it's made up of neurons, you should be able to somehow unify the way you talk about these things. And it's just incorrect. And Sherrington himself kind of thought that it was unlikely that the work he was doing on the soleus muscle of the decerebrate cat was going to somehow lead to principles that would extrapolate to thinking. And in fact, it's interesting that they all got together. We hear about Lord Adrian and Sherrington, and they had a little symposium at the end on mind where they all sort of showed different degrees of consternation and pessimism about how the kind of neuroscience they were doing would not get us all the way up to thinking. Which is correct, by the way. We haven't the slightest idea how thinking works, right? And any attempt to say otherwise is just not really understanding the neuroscience, in my view. But that's not what Mazviita thinks, right? So Mazviita is basically, no, this is not how to think about it when it comes to mind. Philosophy will take care of thinking and mind, and we can just get rid of that. All right? And it is what she thinks. right? It's interesting. In other words, it's actually fascinating that when you read the book, it's a kind of, when it gets to mind, and you need to be embodied, and she calls it the embodied mind. And as the quote I gave you, she's pessimistic whether the scientific project will be necessarily flexible enough and de-simplifying enough to be able to get it, right? I mean, please accept how subversive this book actually is, okay? Now here's the problem, is that this book, fascinatingly, engages not at all with complexity science. One page mentions emergence, right? So in other words, so this is my brother, full disclosure, right? He runs the Santa Fe Institute, right? And he's written, and this is a great little YouTube episode if you want to listen to it, where he makes the point which is essentially complete absence of consideration of emergence in the brain abstracted, right? And the reason why is because it is a perspective that undermines the kind of pessimism in this book, right? And basically, the point is that you have functional closure and protectorates. In other words, the organization of complex systems, and the nervous system is certainly one of them, is that they hive off into protectorates from the inside. It's not epistemological at all, and I'll show you many examples of this. The idea that you have to do this to simplify how to understand a system, that is also true. But these are doing this from the inside. That was the point that Simon was making. Okay, and I'll show you indisputable number of examples of this, right? It's how you organize a complex system. In fact, if you don't have screened off protectorates, you don't have a complex system. So in other words, if you're going to say that the nervous system and the brain are complex, essentially you have to accept this. Right? The high-level sciences neglect the low-level mechanisms for principled reasons and will continue to do so for even in their finished form. They need not, indeed should not, draw on the low-level sciences for their explanatory content. This is Strebbins, philosopher. And then my brother, Emergence 101, when there is no need to look under the hood. Okay? Now, it's a very difficult issue in complexity science to know when you shouldn't need to look under the hood. In other words, you know, you talk about the boiling point of water versus liquid, the dynamics of fluids. Fluid dynamics does not need to know the constituent structure of water, but for the boiling point of water, you do. Now, you know that after the fact. We don't have a meta-theory of complexity to know when you can protect, screen off, hive off, and when you can't. That is frustrating. But after the fact, it's undeniable that it happens. Critical point, emergent properties can be causally or explanatory screened off from many lower level details, yet the kind of emergent phenomenon that arises is still fixed by the underlying low level structure and dynamics. Emergence can be autonomous in operation, but not arbitrary in origin. Okay? This is what Simon meant, and he is correct. Mazviita seems to be conflating these two different aspects. Materialism does not preclude screening off inside the system. It is not an epistemological crutch. The implication is compartmentalized protectorates are inside the CNS. Thus, in the brain abstractive, Mazviita does not see that her two objections are deeply related and can be resolved from within science. But the critical point is this happens a lot actually in evolution and here, is operation at steady state and origin are orthogonal questions. Okay. So autonomous levels and parts in the CNS, so here we are, right? So in a way, Sherrington, working down in the stretch reflex, had no more to say about thinking because he was looking at neurons than a psychologist would. Right? Just because he was operating on these objects didn't give him special access. Now, when I wrote my book on plasticity and stroke, there was this amazing article, and we'll get to compartmentalization and show how hierarchy and compartmentalization and neo-autonomy are true. Right? A point which impressed us repeatedly, this is a 1917 paper, was the seeming entire ignorance on the part of the animal on its awakening from an ablation experiment of any disability precluding its performance of its world activity. This was a lesion in a chimpanzee, unfortunately. We don't do this anymore. Surprise at the failure of the limb to execute what it intended seemed the animal's mental attitude, and not merely for the first few minutes, but for many hours. It was often many hours before repeated and various failures to execute ordinary acts contributed to climbing feeding seemed to impress gradually upon the animal that the limb was no longer to be relied upon for its usual services. Right? And then Sherrington and Leighton say, the impression given us that the forerunning idea of the action intended was present and is definitely and promptly developed as usual. All the other parts of the mode of behavior in the trains of action coming under it seemed accurate and unimpeded except for the role as executant of the particular limb whose motor cortex was injured. And they go on to say that basically that the cortex, the motor cortex, which I think is very apropos of the last talk, was inframental. Okay, so basically, right in front of them, you were seeing complete intactness of the cognitive side of the monkey and just brokenness on the side of the motor. Totally independent. So I'm going to give you lots of examples because I think it's necessary of simplification from within the nervous system. It's got nothing to do with the way we're looking at it. It's the way it's organized. So here are two nuclei in the midbrain that make up what's called the mesencephalic locomotor region, which very interestingly, when it was studied in 1966 by Orlovsky and colleagues, is at a very simple, monotonic, descending, non-phasic command signal with all you needed, a little bit like Spinal Tap, just turn up to 11, right? That all you needed was a monotonic signal and all the complex spatiotemporal dynamics happened in the spinal cord. In other words, you have a hierarchically organized system, and an extremely simplified signal is sent down, and it leads to all the complex dynamics that the spinal cord takes care of, right? This is not simplification from the outside, this is fact. Okay? It is an organizational principle. Give you another example. This is a paper we just have out now, which is all about where did handedness come from. Believe it or not, we don't know why we have handedness and dominance, but you can read our paper. But basically, handedness is fascinating. This is right hand, so these are A's and 8s. And here you have no question A's and 8s, but a little bit like the monkey, they're executed poorly, but the concept is invariant across the two arms. So you have a simplification, a concept, a shape, that is completely compartmentalized and hived off from the actual execution. Okay? And what's fascinating is this is a dissociation for all of us, where we'll have the shape equally well in the two effectors, effector independent, but we will suck on one side versus the other. And the proof that you have the shape available to the other side is with practice you can end up looking like that. Okay. And then you can have the inverse, and this is effector independence, again, that you can do it with your shoulder on the blackboard versus with your hand, and the shapes basically are still present. Okay, so you have a shape representation entirely independent of the execution system, rather like Sherrington's monkey that I was telling you about before. You can have the absolute inverse of that. So this is work we've done on apraxia. So basically, these are patients with left hemisphere lesions, left hemisphere, who are made to do these tasks with their left arm. In other words, not contralateral. This is ipsilateral, already speaking to some higher level representation. Shouldn't say that word, but for shapes I'm allowed. So basically, their execution, unlike us with our non-dominant hand, is perfect, right? What they can't do is they have no idea of the shape. So here they were asked to make this shape, and they can't do it. You get this completely incomprehensible squiggle. So here, what they have is not a motor disorder. They have the complete converse of the monkey and the handwriting, is that they don't have the shape representation, and their motor execution is completely normal. Again, total compartmentalization of assignment. Cannot be refuted. All right? More interestingly, is work that's now been done on the different types of granular prefrontal cortex. So Hoagland has this whole section that I think Mazviita sympathetically talks about at the end of her book, and he's just entirely empirically wrong. what he's saying. So at one point, he says, oh, it's not true that there's this distal proximal relationship and it's narrow bandwidth. Actually, he's wrong. It is narrow bandwidth. In fact, there's no bandwidth. For example, this frontal pole, which is where most of the abstract conceptualization seems to go on, and interestingly isn't present even in other primates, isn't connected to sensory areas at all. In other words, this region has no connection to the outside. So what Hoagland is actually saying is wrong. The most conceptual cognitive parts of the brain are the least connected to the outside world. Right? So if you really had to do, and listen, let's be very clear, in the book, and others like Hoagland, they think that ongoing cognition requires flux from the world. No, it doesn't. I've looked after locked-in patients who have no sensation and no movement at all, and they're completely cognitively intact. Now, this is important to know about these regions because these are the regions we think are responsible for the human difference. So here's a very famous experiment where basically chimpanzees, orangutans, and monkeys and children under 4 fail to hedge. In other words, this idea, here's an opaque tube. If you're under 4, you put your hand under just one. After the age of 4, you go, it could go there, and you put your hands under both. There's no primate, non-human, that has yet done what 4-year-old children can do. Okay? So this ability to entertain counterfactuals on a consistent basis and imagine that kind of cognition, after all, these are very embedded in the world. They have amazing motor systems and sensations. They're fantastic. So if it were just about being connected to the world, they're fine. Right? The reason why they're doing so well, the difference is, is that this strange region in the brain that is capable of doing this. Okay? I just don't understand the 4E point of view. It's just completely, I think that everyone who believes in it should spend just a couple of weeks on the neurology wards with me and they'll be cured of that position for life. Right? Here, this is a very unfortunate condition, semantic dementia from frontal temporal dementia, where you begin to lose, perversely, those regions of the brain that are precisely those responsible for abstraction and thinking. And basically, they begin to break down, while being fluent and grammatical, they just begin to lose high-level concepts first. In other words, they get eaten from the frontal pole backwards. Their motor systems, their sensory systems, their discrimination, totally normal. Okay? They are the opposite of the locked-in, who've lost their sensory system and their motor system and completely abstractly, conceptually intact, and this is the reverse. Okay? So I don't know how many examples to give of these clear Simonian hiving off of systems. Okay? This is work where Penfield, and then since then, where you can put electrodes into the brain and force thoughts. You're literally triggering them from inside the brain. Right? And there are only 2 regions, in fact mainly one, that you can trigger thoughts from, surprise, surprise, prefrontal cortex. So John McDowell, another person in the book that Mazviita seems to have a lot of sympathy for, is also completely empirically wrong. Right? The idea, it can't possibly be that it's coming from inside the brain only. Yes, it is. You can just put an electrode in, out it comes. Okay? So, the whole anti-Simon, Hoagland, McDowell, 4E sort of thing, it's just a complete dead end, in my view. However, it isn't. In a particular variant where I think it's correct, and it gets back to the thing I said before about the difference between your steady-state performance and your origin. Okay, now as long as you accept the difference between those 2 things, I think that there's some possibility of reconciliation. So this is truly remarkable work. I mean, I'm working with Justin Wood on this paper, but Justin Wood is really look at this work. Okay, so he's doing this extraordinary work at Indiana University where he's raising baby chicks in the complete dark to see how much is innate and how much is acquired. It's just tour de force. Talk about technology now allowing the most remarkable godlike. So this is a paper we're writing together along with 2 others. And this is the proper way to think about embodiment. Nothing about ongoing embodiment required for cognition. I hope I've shown you that just isn't compatible with the data. However, what seems to be the case is that there's a domain general structure, which what we think is the cortex. That's why we have cortex in mammals and maybe birds. And then you have body-generated experience. So you have a tabula rasa neural network, randomly initialized. You have experiences, and then you develop domain-specific structures that canalize as a result of this combination over time. So it's absolutely true that the cognitive capacities are the consequence of having experiences and sensory signals, symptoms, and bodies that are basically what your tabula rasa is embedded in to allow you to actually have a bit of structure. And Justin has a paper which I recommend you look at where he's modeled this, and you just change the structure of the retina a little bit, the retina, and the type of representation you have drastically suffers. Okay, so it's almost as though you have this virginal neural network at the heart of the beast, rather like the Wizard of Oz and the Wizard of Oz. Nothing there, really, right? But because of what it's embedded in terms of the rest of the nervous system and the body and the environment, it is conferred upon it useful computational capacity. So from that standpoint, to set things up, I think you could argue for embodiment. But the idea that you need embodiment once you're at steady state and have this set up, I think is completely incorrect. And if you want to look at this work, it's really remarkable. Basically, you have your little chick, and you basically play with it and give it what it has in terms of objects. And then he does this incredible thing where he has a completely connected virginal transformer neural network. And what is unbelievable about this work is you put this neural network in a simulated body, and the representations are, it's remarkable. And I don't mean neural representation, I mean the abilities. So everything that little chick in the dark can do, this thing can do, with very few exceptions. So in other words, what really happened, neural networks are an invention converged upon by evolution and by AI. That's the fascinating thing the cortex does, is it's a structure hoover. It hoovers up structure, and cortex is the ultimate compartment. Right? And it's interesting that this ability to hoover up structure, to do language of thought, object constancy, that the rest of the nervous system doesn't need to do that. Right? So in other words, the whole story is entirely backwards. Right?
John, we've got 5 minutes.
Yeah, conclusion. Look, see? Complex systems simplify themselves so as to coordinate their parts. Each level is near screened off by its own ontological objects. That is a design principle for control, not just something scientists do to explain things. The most cognitive part of the brain, granular prefrontal cortex, is the least connected to the world. The 4E perspective is useless for explaining cognition at steady state. It might be critical for setting things up. How certain areas of cortex lead to deliberative thought is a complete mystery. Philosophers like Mazviita can help scientists with this conundrum. Basal cognition, however, is a complete non-starter and exemplifies the worst kind of extrapolatory abstraction, metaphor gone a bit mad. So I'm kind of amazed after this book, which is criticizing abstraction, seems to have some sympathy for the most egregious version of it, which is to imbue little unicellular objects with these cognitive abilities as metaphor. And actually I recommend, again, it's a bit nepotistic, but my brother wrote a very good paper called Metaphor, Model, and Mathematics, where he talks very much about how easy it is to slip into metaphor when you think, in fact, you're looking at a model and you're not. And I'll stop there. Thanks very much.